Up to this point, we've defined the trigonometric functions only in terms of right triangle trigonometry. However, there is another way to define the 6 trigonometric functions, that is through a unit circle approach. Let's see how this is done. What I have drawn here is a unit circle, that is a circle whose center is the origin and whose radius is 1. From the point 1, 0, I have a real number line, and on that real number line I have the point T labeled. The distance from the point 1, 0 to T we'll call S equals T units. What I'm going to do is take this number line and literally wrap it around the unit circle so that I end up at the point P equals A, B. The distance from 1, 0 to that point P is T units. We could also talk about going from the point 1, 0 in the negative direction so that T is below the x-axis, and then we have the distance S from the point 1, 0 to T is the absolute value of T units. We will then take that red portion and wrap it around the unit circle, and we again end up at some point P equals A, B. The length of the arc from the point 1, 0 to the point P is S equals the absolute value of T units. What we're going to do is define the 6 trigonometric functions in terms of the point P equals A, B as a function of the length of the arc on the unit circle. So let T be a real number and let P equal A, B be the point on the unit circle that corresponds to T. The sine function associates with T the y-coordinate of P and is denoted by sine of T equals B. The cosine will be the cosine of T equals A, the x-coordinate. The tangent will be the ratio of the y-coordinate to the x-coordinate. The cosecant will be 1 over the y-coordinate, provided the y-coordinate does not equal 0. The secant function is going to be 1 over the x-coordinate, provided that the x-coordinate is not 0. And finally, provided that the y-coordinate b is not 0, the cotangent function is going to be the x-coordinate over the y-coordinate. Let's look at an example to see what we mean by this. Suppose that the point P corresponds to some real number T, where the point P is negative 1/2 comma square root of 3 over 2. To help you visualize what I mean by this, suppose we have a unit circle and we start at the point 1, 0. We literally wrap around or cruise around the unit circle until we end up at this point P, where the coordinates of P are negative 1/2 comma square root of 3 over 2. What we want to do is associate with that real number T the values of the 6 trig functions. So the sine of T is going to be equal to the square root of 3 over 2, because the sine of T takes as input the real number T and provides as output the y-coordinate corresponding to T. The cosine of T is going to be negative 1/2, because that takes as input the real number T and spits as output the x-coordinate. Then the tangent of T is going to be the ratio of the y-coordinate to the x-coordinate. So the tangent of T is going to be negative square root of 3. Now we can go ahead and use the reciprocals. The cosecant of T is going to be 2 over the square root of 3, or 2 root 3 over 3. The secant of T is going to equal negative 2. And finally, the cotangent of T is going to be negative 1 over the square root of 3, or negative root 3 over 3.